Now we have your video as well, so welcome on stage. And you have 20 minutes. Good luck.
Wonderful. Thank you so much. So thank you everyone for joining. My name is Maciej Jastrzebski. As our host said, I'm the CEO and co-founder of Align Metal. So we founded the company about 4 years ago, really focused on materials, or developing technologies, commercializing technologies for next generation batteries. And specifically, we were actually working two technology areas. One is production of metallic lithium from sort of raw material chemical sources, and then transforming that lithium metal into really the anode materials that are needed by a lot of the next generation battery technologies. And next generation batteries is something that we hear about, and it's sort of a vague term, but really it's meant to address any of the successor technologies to the lithium-ion batteries, whether that's solid state batteries, whether that's sort of advanced liquid electrolyte, lithium metal batteries, lithium sulfur batteries, even pre-lithiated silicon anode type batteries. And that's a very broad group. In each of those categories, you have multiple other categories as well, or different approaches. But basically, what they all have in common is that they're chasing a substantial improvement in the energy storage characteristics of the battery. And in most cases, the bulk of that is achieved by using a high energy anode material like lithium metal. And what ultimately that translates into is really longer range, cheaper, more efficient electric EVs or electric vehicles. It means in many cases lower cost. In many cases, it means potentially a higher margin for the automakers, thereby accelerating the adoption of these technologies. Now, that's a lot of great benefits. What I think we have to be aware of is that none of those benefits will be realized unless we significantly increase the production of metallic lithium, and unless we significantly drop the cost of the anode materials that are made from that lithium metal, to something that will allow us to make all of these economical and attractive at sort of the mass market scale. And just to give you a sense of the magnitude here, right now the total world production of battery grade lithium metal is around 3,000 tons per year. By most forecasts, that take into account the rate of adoption, sort of the plans of rollout of these technologies, we're looking at potentially 20 plus thousand tons per year of lithium metal demand by the end of the decade, which is basically a growth of sevenfold in 7 years. So it's a substantial challenge. That's what we're working on. Similarly, you have a big anode market that represents the anode next generation anode material demand. It's probably about $10 billion by the end of the decade, growing to about 40 billion by the middle of the next decade. So really, what we're seeing here is an industry. We're expecting this industry to take off sort of on against the backdrop of the broader electrification trend, and that puts a lot of pressure on the companies developing both the batteries and companies such as ourselves working more in the upstream supply chain of the anode materials and the raw materials that go into the anodes, and of course in the other components as well. But basically, this is a whole symphony that has to come together to meet this demand. And so it's really important that as we build out this industry that's done with technologies that are the most economical, the most environmentally friendly, and ultimately give us the greatest chance for the benefits to be realized from all of these disparate next generation battery technologies. And just to give you a sense, as I said, we're working in these two areas, specifically anodes and lithium metal. Where we are today, not us, but the industry as a whole, it's really grafted on or adopted and pressed into service the technologies that have been used to produce primary or non-rechargeable lithium metal batteries. So specifically on the anode side, we're dealing with